Assalamualaikum and hi everyone. I am from Group Elite 5 Kesultanan Perak Sendian Berhad. Today, I will be explaining about our group project. So we were given a project from Lembaga Library Malaysia to design and build a 6-story office building at Ibu Pejabat Lembaga Library Malaysia. A structural design team of our company decided to use Staad Pro software to design this project. We designed based on our client's requirement and the plan of the building, which are dimension and the sizes of the members and columns for this office building has been provided, and the modulus of elasticity of steel given is 205 kN per millimeter square. So referring to the plan given, the building dimension is 30 meter times 100 meter. For column spacing, for short dimension is 9669 meter. For long dimension is 10 meter, while the story height is 4.5 meter. The horizontal wind is 30 kN, acting laterally and full height of the building at both direction of the building. For the slab loading is 15 Newton per millimeter square. And for the loading condition is different per each group. For our group is group 5, which is the uniform distributed load given is 20 kN per meter.
Shall we start from here? Okay, now so we will continue. I will start to the this Staad Pro. We'll go for the modeling first. Now we need to find the properties of the beam and the column. Now for beam, okay, so this is our property. The geometry is Britain standard UB914 times 305 times 253. This is the dimension given that we choose for this beam. Why? And you will know the reason why. Now the properties is that our elastic modulus is 205. The density is 7833. This is quite dense, which is actually quite good. So now this is the beam. So now I will explain why we choose that beam. This is because the ideal dimension is used to obtain optimum normalized ratio for its given strength. With this, we can achieve our desired structure strength. Hence, we can prevent over budgeting for the steel use. So basically, we need to choose the right beam that provides the best strength, that doesn't exceed its failure ratio or does not go below its capability, so that we won't overspend or we won't spend something on that's not strong enough. So that's the beam. Same goes to for the column actually. Oh wait. Oh yeah, this column. So at this column, the geometry is UC 305 305 283. We are using a British standard. In class, we were taught to use it's the American standard, right? But we don't use American. We are all British. Same goes to elasticity 205 7833.41. No, now the reason why we are standardizing all this beam British is because of that, to ease the process of welding of the beam. I'm sorry for the background interruption sound. I'm really sorry. I'll fix that. So now we will continue for the column. Now for the column, the justification is the same as the top one. This is to give the normalized ratio, and the main objective of this steel size dimension is to provide necessary strength for the structure, not too strong and not too low. So that is basically the property of our beam. So now we will I will stop. Kita rehat sebentar bersama mana dia punya application tu? Oh, okay, stop. Allah, apa tu? Okay, now we are back. So we will start with the support page. Alright, the first one is no support. The second one we have support. So basically for this building, the type of support that we use is fixed support. Alright, fixed. fixed part, because because this is a building, you don't use pin or roller because your building will fail automatically. So once that's done, the next part is I will show you about how many, sorry, not how many, we will analyze it. Hopefully there will be no errors, like how I don't think there'll be errors though. All right, let's go. Let's go. All right. I'm all right. See, no error as expected. All right, so done. Okay, so now we are on the post processing part. This is the part where we need to check our beam. We go here first. The beam. Yeah, if we zoom in a bit, we can actually see the shear diagram. The shear. This is the shear diagram. You can see that. This is actually the shear diagram in 3D. All right, so we'll zoom that out. It's taking a bit, so I'm sorry about that. I'm trying to zoom out, but it's alright, any moment now. Okay, done, we're done. So we're gonna, so once that's done, we go for unity check. See, everything is green. You see this gray dotted? Don't worry, it's nothing. Okay, let's go. See, so we'll go here, this section. Failed members are 0 failed members, so that's actually good news. Now we'll go for this part. All, lol. So here we will see all the beams are green. Green indicates that this beam is good to go. You can use this beam, it's not failing. So let's see. This is the actual ratio. This is the allowable ratio. Our actual ratio must not exceed this allowable ratio, because if it exceeds, it will fail. But then it can't be too less, because if it's too less, it means that the structure is too strong. So we are spending more money to provide much more strength that is not needed. So we will go here. Sorry, what's the okay? All right. So this is our beam. Our beam 4 has the highest actual ratio. The normalized ratio is 0.966. By far, I think this is the best ideal choice of a beam for this project. So group 5, elite 5, this is the best. Okay, no other else. So this is 0.966. Now what we need to do is that we click this beam 4. This beam 4 is, we can assume it's a critical beam because it has the highest normalized ratio. So we go to the graph. Now this is sulfate. We're gonna go through one by one. This is all vertical and horizontal load. You will go one by one. So this is UDL. For uniform distribution load, this beam has no moment of shear force acting on it. Why? Because since this is uniform distribution load, it only acts here. If you press here, then there's actually data provided for you. But if you go here, sorry, beam 4, okay, there's nothing. So we go to wind. Same goes to wind. I think we still have shear and moment, but the wind is too it's not strong enough. Because can you imagine if there's a wind, if the intensity is big, and if there's actually shear or moment diagram over here, beam 4, the beam will be wiggling. So we don't want that. So I think that's why when there's wind, there's no moment and shear force diagram can be observed. It means that the structure is strong enough to not be wiggled around by the wind. So I think that's fine, and I think I'm right. So now this is the slab. The slab acts on the most at the bottom of the building. So here we can see at alright, beam number 4, yeah. The moment diagram is like this. It's like a reversed bell shape. This is like a sine graph, cost graph. Yes, confirmed by Yamin. This is cost graph. This is for slab, and then this is self weight. The self weight is the weight of the structure itself. So we can see still the same normal acceptable values. Now we'll go for, okay, this is all the external force that is applied on the structure. So we're done. So for the final question is that we need to find all the shear bending moment force and diagram for all vertical and horizontal forces acted together. So from here we're gonna go and analyze back. Okay, we're done. So we go to post processing mode. Here we go to B. We go to unity check. Alright. So again we do the same thing. Alright. So this is the fun part when all vertical and horizontal load are combined into one case, and such beam is provided, which is UC, no, this is wrong. UC 305 283 and UB 914 305 253 for the level of processing. You can see that in the unity chart, our allowable ratio, the highest one, is actually 1. So we met the exact same number for the normalized actual length, so the failure is 0%. So from here we can understand that this beam that we choose and property will ensure that the building stays firm forever and ever and after. So I think, oh yeah, before I forgot, this is the unity chart. We need to go for the graph. No, this is the graph for beam 4, the most critical one, for all forces combined. You can see this something is happening here. There's a lot of greens here. So we got this moment diagram, which is straight. Can you explain, Yamin, why is it straight? Or he don't want to explain, so it's okay. I'm sure there's a solid reason why it's like this. Alright, but this seems acceptable. And with this, I can approve and I can ensure that this building will be strong enough to withstand any external load and internal load, and it can be used by all species of amphibians, mammals. I think this will be a prosper building for everyone to use. So that's about it. That's the structure. Now, if this proposal is approved, then I think we will discuss more on how this structure can actually be eco-friendly and environmental friendly. We'll discuss about the sustainability of this building after this. Thank you.